Bismillahirrahmanirrahim. Assalamu alaikum, dear friends. You are watching Study with Sheraz, and in today's lecture, we are going to start with the UV visible spectroscopy. So, this is going to be an introductory lecture related to the UV visible spectroscopy, in which we would study about the interaction of UV visible radiations with the matter, with the molecules, and the range of UV visible spectroscopy. So, first of all, we would try to understand the basic concepts of the UV visible spectroscopy. So first of all, it's a type of absorption spectroscopy. So as the word indicates, it means that it is a type of spectroscopy in which when the UV visible radiations are made to fall on a molecule, the molecule absorbs the radiation, and as a result of the absorption of radiations, there occurs certain transition in the molecular energy levels of the molecule, and that lead to the formation of a UV visible spectrum. So molecules interact with EMRs falling in UV visible regions of electromagnetic spectrum. In earlier lectures, we studied about the electromagnetic spectrum, and we studied about the ranges of the electromagnetic spectrum, and in that we talked that there exist 7 regions in the electromagnetic spectrum, and 2 of the regions are UV and visible. So in UV visible spectroscopy, the radiations that are made to interact with the molecules are falling in the UV and visible region of the electromagnetic spectrum. And the UV visible spectroscopy is also known as the electronic spectroscopy. So why it's known as the electronic spectroscopy? Because the absorption of UV visible radiations by the molecule leads to the excitation or the transition within the electronic energy levels. In a previous lecture, we talked about the molecular energy level, and in that lecture, we learned that an isolated molecule is associated with a large number of energy levels. And among the various molecular energy levels, one is the electronic energy levels, and between which the electrons are transited from the ground to the excited state. And as the absorption of UV visible radiation leads to the excitation of valence electron between the various energy levels, between the various electronic energy levels. So that's why this spectroscopy is also known as the electronic spectroscopy. If we talk about the wavelength ranges of the UV visible spectroscopy, so radiations falling between the wavelength range from 10 nanometer to 800 nanometers are used within the UV visible spectroscopy. And this region can be further divided into 2 regions. As I have mentioned earlier, there are 2 regions. One is from 10 nanometer to 4 nanometer. That is basically the UV. That's the ultraviolet region of the electromagnetic spectrum. And the second one is the visible region. So the region of electromagnetic spectrum ranging from the 400 to 800 nanometer is the visible region of electromagnetic spectrum. And this UV region or the ultraviolet region of electromagnetic spectrum can be further divided into 2 sub-regions, and that is the far or vacuum UV region, and the other one is the near or quartz UV region. So far or vacuum UV region ranges from the 10 to 200 nanometer. In this region, the wavelength of radiations is very small and the energies are very large, and it's known as the vacuum UV region because whenever we use the radiations of these wavelengths, we have to evacuate the system, because in these regions the atmospheric gases just like the nitrogen and oxygen, they start absorption. So that is not desired. So in order to remove the undesired absorptions, the whole region should be evacuated. That's why it's known as the vacuum UV region. The other one is the near or quartz UV region. So that ranges from the 200 to 400 nanometer, and it's also known as the quartz UV region because you people know that quartz is a type of material that is used to make the sample holders or the cuvettes that are used in the instrument. And in these regions, the quartz material does not show enough absorption. So that's why the quartz qubits can be used in that region. That's why this region is known as the quartz UV region. So next we talk about the process of electronic transition by the absorption of electromagnetic radiations of the UV visible region. Absorption of UV visible radiations causes excitation of valence electron from the ground state to the excited states. The one thing is important that you should not say that it's the electronic transition. Basically the valence electronic transition, because the electrons can be from the inner shell, and that is related to the X-ray crystallography. That's not related to the UV visible radiations. So whenever you talk about the UV visible spectroscopy, you should say that there are the electronic transition of the valence electron. So whenever a molecule absorbs radiation in the UV visible region, the valence electrons of the molecule are raised to an excited state. From ground state, they are shifted toward the excited states. And a word mentioned here is from HOMO to LUMO. HOMO stands for highest occupied molecular orbital, and LUMO stands for lowest unoccupied molecular orbital. So whenever UV visible radiations are absorbed, the electrons are promoted from the HOMO toward the LUMO. So look at this diagram, in which there are two energy levels that I have shown here. It's containing the 2 electrons, it's containing the 6 electrons. That's not important that which energy levels are that. That is just going to be a clearance of concept. So this energy level is the highest energy level that is containing the electron, and no energy level above it is containing the electron. There may be another energy level above it. So these two energy levels are empty. They are not containing electron. But this is the highest molecular orbital that's having the electron. That's why it's called the HOMO. And these two levels are empty. But among these, this is the lowest unoccupied molecular orbital. So that's why it's called the LUMO. So whenever the radiations are absorbed, the electrons are shifted from the HOMO toward the LUMO. Lambda of the radiations depend upon the energy gap between HOMO and LUMO. As in the lecture of the molecular energy levels, we talked that the radiations that are required for the transition between any molecular orbital are related to the energy gap between these energy levels. So if we are going to irradiate the molecule with a certain energy or with a certain wavelength of the radiation, the wavelength is related to the energy gap between the electronic energy level. So how much is the gap between HOMO and LUMO decides that which wavelength should be used for the excitation. If the energy of radiation is below the energy gap, there is no transition. If it's higher than the energy gap, there is no transition. The transition would only occur when the energy of the irradiated radiation is equal to the energy gap between HOMO and LUMO. So if the energy gap between these two energy levels is equal to the delta E, that's equal to h nu, so the incoming radiation must have the energy equal to h nu. Only in that condition the electronic transition would be possible. So whenever this radiation is being irradiated on the molecule and the molecule absorbs the energy, one of the electron from the HOMO is shifted toward the LUMO. This is ground state, this is excited state. So upon the absorption of radiation, excitation occurred and one electron has shifted from HOMO toward the LUMO. So this is all about the introduction and concepts of the UV visible spectroscopy. In the upcoming lecture, we will talk about the UV visible spectroscopy in detail. So if you have any question related to this lecture, you can post your question in the comment section. We will meet in the next video. Up till then, Allah Hafiz.